Today we're going to talk about order of operations when you have fraction bars involved in your problem. So fraction bars can be kind of frightening, but really they just mean division, especially in a case like this. So if you have a problem like this, it means that there are implied parentheses on the top and implied parentheses on the bottom. So they're kind of invisible, but basically the fraction bar is a grouping symbol. It tells us we have to group the top and do that, and then group the bottom and do that, and then when we're all done, we divide. So I've written the steps out here. It says simplify the top using order of operations. So in this case, we would do 8 plus 6 is 14. And then we would simplify the bottom using order of operations. So again, in this case, 9 minus 2 is 7. And then when we were all done simplifying the top and simplifying the bottom, we would divide if possible or reduce. So 14 divided by 7 is 2. So in this case, our answer would be 2. And then I've listed the order of operations down here just so we have them to go through them when we need them. So we're going to start off with an example. So example 1 is going to be 11 plus 3 with our quotient grouping symbol or fraction bar divided by 7. And so in this case, we simplify the top, we simplify the bottom, and then we divide. So 11 plus 3 is 14. And then on the bottom, there's nothing to simplify. So when that happens, you just sort of bring it over. And then 14 divided by 7 equals 2. So our answer is 2. And you'll notice that when we have a big problem that involves a fraction bar, I actually do use equal signs. Normally when I'm simplifying an expression, I don't. But here I do because it kind of makes sense to write things horizontally instead of vertically. So that was a simple one. Let's try a little bit harder one. Example 2. 20 minus 10 divided by 2 over quantity 4 minus 3 times 5. Okay, there's definitely a lot going on here. So remember, back to our steps, we simplify the top using order of operations, we simplify the bottom using order of operations, and then we divide. So looking at the top, this is why the order of operations are so important, because it's really tempting to say 20 minus 10 is 10, but that's not the correct first step. If we look down here at our order of operations, we start inside parentheses. Well, I don't have parentheses on the top, so I can skip down to the bottom. Once parentheses are gone, I start with my exponents and roots, and I don't see any exponents or roots here. So then I move on to multiplication or division left to right. And I do have division. So 10 divided by 2 is the thing I need to do first. And it might be smart in this situation to actually treat each of these like separate expressions to simplify. And then when we're all done, we'll divide. So I'm going to rewrite the top, 20 minus 10 divided by 2. And I'm going to go ahead and do the division first. 10 divided by 2 is 5. And 20 minus 5 is 15. So coming back up here to my original problem, I'm going to go ahead and put my equal sign and put my fraction bar, and I now know that the top simplifies to 15 when I use order of operations. And now I'm going to come over here and I'm going to simplify the bottom. So I have 4 minus 3 times 5, but the 4 minus 3 was in parentheses. So going back to my order of operations, I always want to start inside parentheses. And there's only one thing inside parentheses, and that's the 4 minus 3. So I'll go ahead and do 4 minus 3 is 1. I've done everything inside parentheses, so I don't really need them anymore. And I'll bring down my multiplication symbol, and I'll bring down my 5, and 1 times 5 is 5. So I now know that the bottom simplifies to 5. So I'm almost done. 15 divided by 5 is actually a whole number because 5 goes into 15 3 times. So my overall answer here is just 3. Okay, example 3. So example 3, 10 minus 4 divided by 2 plus 2 times 3. And I may end up doing a little bit of this in my head. So remember, we first simplify the top using order of operations, simplify the bottom using order of operations, and then divide. So the top is real simple. There's just one thing to do. 10 minus 4 is 6. And then I'll kind of bring over the fraction bar. And then on the bottom, I really need to pay attention to order of operations. There are no parentheses, so I'm looking for exponents or roots. I definitely don't have any of that. Multiplication or division comes next, and I do have multiplication. So if you need to do this on paper, you certainly can. I'm going to go ahead and do it in my head. I know that 2 times 3 is 6, and 2 plus 6 is 8. And now I have kind of an issue here because I know that 6 divided by 8 is not going to give me a whole number. And in fact, I know that my answer is less than 1 because 6 is smaller than 8, so 6/8 is less than a whole. So the way I'm going to deal with this is, since I know it's not going to be a whole number, I can't really divide, I can reduce the fraction. So I'm going to treat this like a fraction, and I know that the biggest number that goes into 6 and 8 is 2. So I'm going to go ahead and divide the top by 2, and I'm going to divide the bottom by 2 just to reduce it. And 6 divided by 2 is 3, 8 divided by 2 is 4, and I can't think of anything that goes into 3 and 4, so my answer is 3/4. It's just a fraction. So remember, don't freak out if you end up with fractional answers. It doesn't mean you're wrong. The next part of our lesson deals with evaluating algebraic expressions. And the way the problem is named makes it sound more complicated than it really is. This is an example of a problem you might see. It says, evaluate when x equals 3, y equals -2, and z equals 5. And then it gives you an algebraic expression. And we call this an algebraic expression because there's a variable in it, that's z. Normally we use a variable to stand for something we don't know, but we actually know the value of z. It's 5. So there are really just 2 steps here when evaluating algebraic expressions. The first is to replace each variable, which is just a fancy way of saying letter, with the number given. And I might use the term here, plug in. Okay, that's really what we're doing. We're just plugging in a number for a variable. So in this first example, I'm going to rewrite my expression. The only difference is I'm going to replace the z with 5 because it told me that z is equal to 5. So normally when I plug in, I use parentheses just to show I'm replacing the z with 5. Now, hopefully you remember from the last lesson that this means multiply. In fact, 2z means 2 times z. And I have a little reminder over here. It says, remember 3n means 3 times n. When you have a number next to a variable or a number next to a variable, there's an invisible multiplication sign there. So the next step is just to use the order of operations to simplify. So coming down here to our order of operations, even though I have parentheses here, there's nothing to do inside of the parentheses. So I can skip down to this step. And I start with exponents and roots, and I don't have any of those in this problem. So then I go to multiplication and division left to right, and I do have some multiplication. This just means 2 times 5. 2 times 5 is 10. And then just like in our last lesson, we're going to bring everything else down. So the minus 15 comes down, and I'm down to just one operation, that's subtraction. And keep in mind that since 15 is bigger, it's sort of like having 10 good guys and 15 bad guys fighting. The bad guys are going to win by 5. 10 minus 15 is -5. Box in our answer, and we're done. Example 2. Y plus 4. And we're going back to the very top where it told us what x, y, and z are. And in this case, I'm not worried about x, I'm not worried about z, because the only variable in my expression is y. And y is -2, so I'm simply going to replace the y with -2. And in this case, it doesn't really make much sense to use parentheses when I'm plugging in because the y is kind of off by itself. So I don't need them to keep organized. But if you wanted to put parentheses there, you certainly could. And then if I have 2 bad guys and 4 good guys and they fight each other, the good guys are going to win by 2. -2 plus 4 is +2. So it's as simple as that. You just plug in, simplify using order of operations. it will get a little more complicated, of course. So let's look at example 3. 10 minus 2 times the quantity x plus z. Again, going back up to our 3 numbers that we were given, the 10 and the negative 2, or the 10 and the minus 2, are going to stay put because those aren't variables. But the x and z, I will need to plug in the 3 for the x and the 5 for the z. So I'm going to come down here and do that. I've got 10 minus 2, parentheses, and then x is 3 and z is 5. And the only tricky thing here is order of operations. This is a pretty straightforward expression, but lots of people are tempted to just move left to right and start by doing 10 minus 2. Remember, subtraction does not come first in order of operations. I do have stuff happening inside the parentheses, and there's only one thing going on, and that's 3 plus 5. So I'm going to go ahead and start there. 3 plus 5 is 8, and I'll bring everything else down. And don't forget, there's invisible multiplication here, and if you want to go ahead and put that dot in to help you, you can. So now the parentheses are gone because inside these parentheses there's nothing to do, and I'm left with subtraction and multiplication. So coming down here, there are no exponents and roots, but I do have multiplication. So I have to do that multiplication first. Don't get distracted by that 10 minus 2. So 2 times 8 is 16, and I'm going to bring everything else down. 10 minus 16. So here, if we've got 10 good guys and 16 bad guys and they fight, all the good guys are going to get killed, 10 of the bad guys are going to get killed, and there are going to be 6 bad guys left, or negative 6. So our answer to example 3 is negative 6. We're just going to do one more together. We'll call this one example 4. 5 plus x plus y squared. And again, we're using these same values for x, y, and z. And I don't have to worry about z here, but I do need to replace my x with 3, and I need to replace the y with negative 2. So when I do that, I get 3 plus, and the reason I'm showing you this example is whenever you have exponents, you have to be extremely careful, and you have to plug in using parentheses. And the reason we have to do that is y squared means y times itself, or in this case, negative 2 times itself. And we know that a negative times a negative equals a positive. I just want to show you over to the side what would happen if we left those parentheses off, okay? It turns out, and you can test this by typing this into any calculator that you have that does order of operations, these two are going to come out with different answers. If you plugged this into a calculator, it would give you negative 4. But if you plugged this into a calculator, it would give you positive 4. And the reason is that in order of operations, you always do exponents before you do multiplication. And even though it doesn't look like it, negative 2 is sort of like multiplication. It's negative 1 times 2. And so here it would be 4, and then it would throw the negative on, negative 4. Whereas down here, it's actually doing negative 2 times negative 2, which is positive 4. So when you're dealing with exponents, it's very, very important that you plug in using parentheses. So now that I'm done plugging in, I'm going to come down to my order of operations, and there is nothing happening inside parentheses, so I start with exponents and roots. And I do have exponents, as we just talked about. Negative 2 times negative 2 is positive 4. So I'll go ahead and bring that down. And now I'm down to just addition. So I move from left to right. 5 plus 3 is 8. Bring down the plus 4. 8 plus 4 is 12. Box it in, and we're done.